All right, so now we're going to start talking about Chapter 8. Best practices, I would recommend that you have the printed notes that I provide for you online in front of you, and then follow along this lecture on YouTube so that you can get the best of everything that I'm offering. The document that's there in front of you is pretty thorough, so I will not be reading most of that to you. I'll just assume that you're reading it as we go, and that you're following along that way. Now, the Chapter 8 deals with conic sections, nonlinear systems, and parametric equations. We're going to start by revisiting circles and parabolas. But before we do that, I want to talk about conic sections. A conic section is when you have what's called a double napped cone. That's two cones that are tip to tip whose bases are parallel to each other. And by the way, these cones are infinite in size. And if you intersect the double napped cone with a plane where the two intersect each other, you'll get one of the four conic sections. If the plane is held parallel to the base of the cone, you'll get a circle. Different size circles can be achieved by moving the plane closer to the common tip of the cones or further away. If you tilt that plane slightly, the intersection of the cone and the plane is an ellipse. If you tip that even further, and in fact you tip it to exactly to the point where the plane is parallel to the side of the cone, you get what's called a parabola. And if you tip it even further, such that the plane for the first time crosses through both of the cones, you get what's called a hyperbola. And a hyperbola has two branches. Where you're touching the two cones, you'll get the two branches. So that hopefully makes sense. All right, so let's talk about a circle. The definition of a circle states that we're going to have a set of points equidistant from a fixed point, HK. HK is a very commonly used point name in this section. For all four conic sections, HK will be a particular special point. So please pay attention to that as we go. So we have a fixed point, and we get the set of all of the points. Well, let me try to draw a little bit better. All of the points. Yeah, let me try that again. Let me see if I can make that better. And there we go. So if I draw the set of points that are equidistant from that fixed point, which by the way is called the center of the circle, this set of points creates the circle. And if we generically call any point on that circle xy, the thing that makes this a circle is that the distance from the center HK to any point on the circle is always the same. And we call that distance r for the radius. Now, in order to understand how the equation is derived, I want you to remember that there's something called the distance formula. So the distance formula has you take the square root of the x-coordinate of the second point, x sub 2, minus the x-coordinate of the first point, x sub 1 squared, plus the difference of the y sub 2 and y sub 1 squared. And that gives you the distance between the 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. For this particular problem, since we're defining the circle to be the set of points whose distance from the center is always the same, we can take our generic point for any point on the circle, call that the second point, so that's x, minus h, the x-coordinate from the other point we're measuring between, plus, I forgot to say squared, I wrote it but didn't say it, the difference of the y's, that's going to be y minus k squared. And the distance we'll call r. And to arrive at the standard form for the equation of a circle, we'll square both sides of this equation, obtaining this equation, the quantity x minus h quantity squared plus the quantity y minus k quantity squared equals r squared. That's the standard form for the equation of a circle. Now, if we are asked, for example, to find the equation of a circle with given information, this one in your notes is radius is 6, center is negative 3, 4. That's going to be the quantity x minus the x-coordinate of the center of the circle, x minus negative 3, which we'll generally rewrite as x plus 3, quantity squared, plus y minus k, which is 4 in this problem, quantity squared, equals r squared. Since the radius is given to be 6, 6 squared is 36. And that's the equation of the circle that we were asked to do. Now, the next part of that same question is to graph the circle. Whoa, let me try that again. It's harder than I thought to draw a straight line using this. And it doesn't seem to go as far as I want. Oh well. So if we have a center of negative 3, positive 4, that puts our center right there. And then since the radius is 6, we're going to want to go from that point that we just plotted, 6 in every direction. You write a few more tick marks on our axis here. Let me go up here just a little bit more. I can tell you right now that I'm not drawing this perfectly, so it may or may not actually look like a circle when I'm done, so I appreciate your indulgence on that. All right, so let's see. What we want to do is move from that point, negative 3, 4, 6 in every direction. Well, the easiest way to measure 6 is in the cardinal directions, up, down, left, and right. So I'm going to go up from that point 6, down from that point 6, to the left of that point 6, and to the right of that point 6. And then do your best to draw a circle through those points. I told you it wouldn't look great. Oh well, it's not bad. So that's the circle. Then the next part of that question is to find the domain and the range. Of course, the domain is a set of x values that are used. So if you look at our graph and just look at the coordinates, the x coordinates of the leftmost and rightmost points, that's going to put us at negative 9 on the left side and positive 3 on the right side. So that's our domain. The range, using the same thought process, is going to be the lowest y value to the highest y value that's graphed. And so that will end up being, the range will end up being negative 2 to 10. All right. So the other thing that can be asked in this same vein is, instead of being given the coordinates of the point and the radius, you could be given the information about the circle and asked to write the equation. I actually got a little bit ahead of myself. I forgot there was another example. So let's do this next one. The circle is centered at the origin and has radius 3. So that means that the point hk is 0, 0. So x minus 0 squared plus y minus 0 squared equals the square of the radius, which is 3. So 3 squared is 9. Okay. That simplifies to be x squared plus y squared I'm getting used to this, you can tell, equals 9. All right, so that's the standard form of the equation of the circle that was described. The graph of it set up my axes. By the way, if I forget to do this, partly it's because it's difficult to remember everything when I'm doing this in a brand new way. So I, again, appreciate your indulgence. You should always label your axes. All right, so at any rate, the center of the circle is at the origin, so there's a dot right there. And then, since the radius is 3, we'll go from the center up 3, down 3, left 3, and right 3. And do our best to draw a circle that goes through those 4 points. All right. And the domain of this circle is -3 to 3. And the range is also -3 to 3. Alrighty. So, the general equation for the equation of a circle is going to look like this as soon as I get this moved down so that I can have room to write, is in the form x squared plus y squared plus dx plus ey plus f equals 0. Let me write that. X squared plus y squared plus dx plus ey plus f equals 0 will be the general form of the equation of a circle. What this is coming from as a basis, let me just say this off to the side very quickly, is that we're dealing generally with all conic sections with something that has this form: ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And it just so happens that if b is 0 and a and c are the same number, then you have a circle. D, E, and F, well, all of those letters, A, B, C, D, E, and F, are real numbers. And if it's a circle, then it will have the same number for A and C, and B will be 0. All right. The graph of anything that's in this form, x squared plus y squared plus dx plus ey plus f equals 0, will be one of these things. It will either be a circle, a single point, or a graph that's empty, contains no points. And the way that that can happen is that if you have x squared plus y squared, which is making it the simplest case possible, x squared plus y squared equals 0, then there's only one ordered pair that would make that true, 0, 0. So if your radius is 0, you get what's called a point circle. It consists of that one point, the center. If you had, for example, x squared plus y squared equals a negative number, you know that the squares of numbers give you positive or actually non-negative answers. If you add those together, the answer will also be non-negative. If the equation is such that it's equal to a negative number, that can't happen, which means the graph would have no points. So, looking at the first example, example A, they ask us to discover when the equation is given in this general form. Oh, oops, I got ahead of myself, made a mistake. Sorry. They ask us if this is, or which of those three possibilities we have. Sorry, I need to be able to split my attention between a couple of things at the same time. I'm getting better at it, but still not perfect. So I'm going to try to copy this equation down correctly that we're supposed to work with. All right. Very good. So what we're going to have to do to get this in the standard form, that is the x minus h quantity squared plus y minus k quantity squared equals the radius squared, we're going to have to use a technique called completing the square. To complete the square, when there's a squared variable like x squared and a linear term like minus 6x, we can complete the square by finding a number that we could add to that so that it would factor to be x minus h squared. So to find that number, the rule is that the coefficient of x squared or y squared has to be 1 to do this process. And so I'm going to need to look at the linear coefficient in order to determine what completes the square. This is what I'm doing right now is I'm putting this in the form I generally use to get started, which is get all the x's together if they're not already together, get all the y's together if they're not already together, and then any constant you see, you can just move it to the other side for now. To complete the square, as I was mentioning earlier, look at the coefficient of x, which in this case is negative 6. Take half of that number. Half of negative 6 is negative 3. Square that result. The square of negative 3 is 9. And add 9. Now, because I've done that on the left side, I have to do something on the right side to keep the equation in balance. So I'm also going to add 9 on the right. To complete the square for y, half of 10 is 5. 5 squared is 25. So I'm going to need to add 25 to both sides. As it turns out, in hindsight, I could have left that 25 where it was and used it to complete the square for y, but that's all right. No harm is done. We'll just accept that. So this trinomial x squared minus 6x plus 9 will factor because we completed the square. We went through that process by taking the square root of the first term, so the square root of x squared is x, keep the sign of the middle term, so minus, and then take the square root of the third term, the square root of 9 is 3. And then close the parentheses and put a square on that. And that we've now factored x squared minus 6x plus 9. Doing the same thing with the second trinomial, that will factor to be y plus 5 squared equals, and then do the arithmetic on the other side, and you get 9. And since we got a positive number 9, that makes it a circle. And we're asked to graph it. So we'll do that here momentarily. Give Give myself a little bit more room. Now when you're graphing from the equation like we were given for part A, I do want you to realize that part of the work here is going to be identifying the major parts of the circle. That is, what are the coordinates of the center? In this case, it's 3, -5. You might want to keep in mind that you look for the opposite of the number you see. Since I see a -3 with x, that means the x coordinate of the center will be +3. Likewise, since the number with y is +5, the y coordinate of the center is -5. And then the radius is the square root of the constant on the right side. The square root of 9 is 3. So once you've found that information for this circle, set up your axes. One, two, three, a few more marks. A few marks this way. And then -5 is the center's y coordinate, which will be right there. And then I need to give myself a few extra marks. And maybe a mark or so up here. All right. So the center is at 3, -5. So plot that point. Then use the radius to find the 4 major points in the 4 cardinal directions. So from there, up 3, down 3, right 3, and left 3. And then do your best to draw a circle. Remember, this circle is a curve, so it shouldn't look straight, even though sometimes they look sort of straight. Try and make it look curvy instead of straight. Because if you make it straight, it looks like a diamond, and circles are not diamonds. So you put diamonds on circles. That's called an engagement ring, guys. Just saying. All right, so anyway, that's the graph of that one. All right, so let's do B. All right, so the equation we're given for B is x squared plus 10x. And what I'm going to do is I'm going to go ahead and write this in the order I like it and spread things out a bit. So leave a blank space here so that you can have the place to put the number that completes the square. Then got all the x's together. These are all the y's together. And that constant I'll move to the other side of the equal sign. All right, so now I have to figure out what number completes the square for the x's. Coefficient of x squared is 1, so we're ready to go. Half of 10 is 5. The square of 5 is 25, so I'm going to add 25 on the left side to complete the square for the x's, while at the same time adding 25 on the right side to keep the balance of that equation. Then the number that completes the square for the y's is half of -4 is -2. The square of -2 is 4, so I'm adding 4 to complete the square, and 4 on the other side to keep the balance of the equation. All right, so this will factor to be x plus 5 squared plus y minus 2 squared equals, let's see, -3 and 25 plus 4 is -4. Oh, well, that's impossible because 2 perfect squares added will give a non-negative answer, never a negative answer like -4. So because -4 is less than 0, there will be no graph, or there'll be no circle. No circle, and the graph is, well, There's no graph. The graph is empty. The graph contains no points whatsoever. Alrighty. And then C. 2x squared plus 2y squared. Oh, I'm going to go ahead, like I said earlier, I'm going to go ahead and rearrange things. So minus 6x plus 2y squared. I didn't leave a space, and you'll see why in a second, because I'm not quite ready to complete the square as it is. Plus 10y. Oh, they already have the constant on the other side. Good. Equals 1. Now, as I said earlier, to complete the square, and you don't want to forget this, the coefficient of your squared variable has to be positive 1. And if it's not, you're going to have to factor to make it so. So I'm going to factor the 2 off of all of the x things, which will leave x squared minus 3x. And here's where I'm going to leave that blank space. Plus, and the same thing for the y squared. To complete the square, I have to make it 1y squared. Factoring off the 2 will make this plus 5y inside equals 1. All right, so half of negative 3 is negative 3 halves. Squared is 9/4. Now, you may think I need to add 9/4 to the other side. You're almost right if you think that. Keep in mind, if I were to redistribute the 2, that wouldn't really be a 9/4. It'll be 2 times 9/4. So I've really added 2 times 9/4 to the right side, so I need to remember that I'm adding 2 times 9/4 also on the other side. Pretty common mistake people make at first is to add 9/4, not 2 times 9/4 at this stage. All right, then completing the square for y, half of 5 is 5 halves. The square of 5 halves is 25/4. And just like we did before, I didn't really add 25/4 to the left side. I actually added 2 times 25/4. So I have to add 2 times 25/4 to both sides. Okay, so completing the square is completed. Now the factored form will be x minus 3 halves squared plus 2 times. The factored form of that will be y plus 5 halves squared equals, let's see, we need to do all that arithmetic correctly. It should be 18. Now the standard form doesn't allow for those coefficients, those 2's to be there, so I'm going to have to divide both sides of the equation by 2 in order for it to be in standard form. So I'm dividing everything by 2. And there we have the equation. Now, is this a circle? Is it a point circle? Or is there actually no graph? Well, because 9 is a positive number, that means we actually have a circle. So this positive 9 implies that we actually have a circle. Now we're supposed to graph it. So the center of this circle is positive 3 halves, negative 5 halves, and the radius is the square root of 9, 3. Of course, with the fractions there, it makes it a little bit more challenging to graph. So I'm hoping we don't have a whole lot of those with fractional things there like that. It's not very much fun. See? 3 halves is 1.5, so that's what I'm keeping in my head, so that's 1.5, to keep that in mind. And then negative 5 halves is negative 2.5, Hope I gave myself enough room here. All right, I think I may have messed up my scale a bit. Yeah, those things don't look even. Well, pretend. So 3/2, -5/2 is about right there. We're just sort of guessing where it is, so that's okay if it's not perfect. Then from that center point, we're going to go up 1, 2, 3. To the right, 1, 2, 3. To the left, 1, 2, 3. And down, 1, 2, 3. Well, you can tell because my Y and X scales are different, this won't really look like a circle. So this is why you want to be very careful with the spacing on the X and Y axis. If you're going to graph a circle that looks like a circle, they have to be the same. That's a really flattened out circle, but if I'd done this on a well-constructed grid, it would have been just fine. All right, so that's going to be the end of this part, and we'll continue